Hi, everybody. Thank you very much for your time this morning. My name is Martin Harrop. MSA, the safety company. We're just round the corner there. We'd love to see you later today after the presentations. So great to see you. Our subject today that we're addressing this morning is safety as applied to the breakout detection of hydrogen process. Essentially, it's only when we have unrelated operator error, control system failure or breakdown of containment that we look towards the efficiency of the detection of our equipment, fire and gas safety system, shutdown system or physical containment. This is a point where we need to review what we consider to be safety. Is it safety overarching, covering all possibilities, or are we looking to perceive safety? Perceived safety. Perceived safety could be, for example, if we look at, say, driving down the road. If we drive down the road and we see some traffic lights that are on red, we should stop. People, pedestrians, and other road users would expect us to do that. However, if something changes, suddenly the driver has an issue, or the car fails, clearly the red traffic light means nothing. And this is where we may have an issue. And along with the potential of the traffic lights themselves, the system failing, they're all factors relating to safety. However, within these various factors is where we could have a problem. A process or process control system is known. And to a certain degree, the safety of it and its containment is controlled by ourselves through the design of the process. All the controlling devices, flow, temperature, pressure, etc., are directly connected to the process medium. Therefore, if the process is contained, the system will have full control and we should be safe. The issue that we face with the process, the control system fails. We may have an operator error, we may have a loss of containment, or potentially an issue due to an external situation, in all cases causing danger or a dangerous condition. This is the point at which we rely on the detection selection, the fire and gas safety system, or the shutdown system. However, returning to my earlier point of perceived safety, this is where again we may have some decisions. Clearly, we could just scatter gas and flame detection equipment devices throughout the plant. But is this helping us or just making us feel better as to what the actual offering or the personnel and investors? So are we getting value for money for just throwing things about? I'll briefly touch upon positioning of detectors and how this can be achieved better later in the presentation. It is clear, however, that early detection of any failure of the process is important. And the following slides will demonstrate some new technologies that facilitate early detection of process failure before they reach a critical level, at which point they may pose a danger to personnel, life, and plant. Regarding undetected leaks, we could say that hydrogen is safe. However, surely this is only if it's contained within the process itself. Hydrogen flies away. Well, not really, and we will actually review this on a later slide. Our plant doesn't leak. Clearly, this is something that operators can say or do say, but how do we really know? Are we being overconfident? And also safety knowledge. Maybe we have some gaps regarding the EX requirements and zoning of any particular hydrogen plant or hydrogen system. Regarding hydrogen pressure releases, note that the process instruments have no way of seeing or being aware of the actual leak. We can see from the slide here, hydrogen is not flying away. This being due to the location of the leak and also due to the hydrogen being at high pressure, in this example 100 bar. The example is in an open area with a wind speed of 1.5 meters a second. We can also see that at 5 meters distance, we still have 100% LEL. And at 11 meters, we have 50% LEL. Noting that the LEL, lower explosion limit of hydrogen, is 4%. And it is also flammable up to 77%, its UEL, upper explosive level. Another significant point regarding hydrogen is that while hydrogen has some similarities to other hydrocarbons, methanes, etc., noting that hydrogen isn't a hydrocarbon, the risk is much higher due to the speed of the flame propagation through any actual leak. This clearly will create potentially a significant explosive situation if ignited. Hydrogen flame detection. Both of these pictures are actually the same picture at the same time of a hydrogen jet fire. However, on the left, we're showing a visual representation of the system, and on the right, we're actually looking at the same area using a thermal imaging camera. Note that the flame is not visible to the naked eye, and also note that the hydrogen flame gives off very low thermal radiation. So again, not the easiest of gases to actually detect once released. Okay. We need to have within the system design, we need to have a plant evaluation. What are the main components, structures, obstacles, potential leak sources, and what are the pressures throughout the system? What technologies, and what are the efficiencies based on their placement? Ultrasonic leak detection, UGLD, which has a detection capability down to 2 bar, conventional gas detection, and in this case, we're offering flame. Positioning and reliability of the design, we could look to the fire and gas mapping. Potential locations of leak sources, the environmental conditions, the wind speed, wind direction, and also if this is in exposed areas. Okay, very simply, where are the risks? Simply, there are the main value chain components in the green hydrogen plant. These areas being the production area, the compression and distribution area, and the storage. Very simple. We're not going down to real detail because we're not going to design the hydrogen plant for you today. What are the risks? Again, across the 3 main areas, production, compression and distribution, storage, we clearly have potential for hydrogen leaks, which in any enclosed area could cause oxygen depletion and/or breakout of flame, all of which would create a significant danger to life and process if undetected. Protection layers and the technology for hydrogen hazard detection. The technologies that we will discuss are ultrasonic, conventional gas detection, note, not infrared. Clearly, as we said, it's not a hydrocarbon, so infrared is of no use at all. And flame detection using UVIR. We would like to note that the units offered by MSA, all, if used in the correct configuration, offer fail-safe operability. All using MSA's patented sensonic self-test, TrueCal, and diffusion supervision, plus continuous optical path monitoring from the flame, which is our COPM system. Again, please join us later at the MSA stand, which is B58, just at the back, and we can discuss these capabilities in more detail later. Okay, regarding the hydrogen plant fire and gas system design, first again, we do the plant evaluation. We need to understand the main components again, the electrolyzer, the compressor storage areas, the manifolds, pipe connections and flanges, etc. Where are the dangers within the plant? This can be done, obviously, using mapping, fire and gas mapping again, something that, again, we can discuss later. Then identify the structures, the walls, the pipe racks, the roofing that may cause obstruction to any detectors. Also, any confined spaces. We need to evaluate the hydrogen's physical state. Is it gas, liquid in a specific area? Also, what are the pressures throughout the plant? Because clearly it could be a very high pressure, it could be liquid, it could be. So we've got to be very careful as to how we actually deal with this. Lastly, we need to review any potential leak source based on that criteria we've just discussed. Technology evaluation. Once areas of concern are identified, look to the technology evaluation and review the available detection principles. Again, ultrasonic leak gas detector, UGLD, for pressurized gas areas. However, taking into account any obstacles, walls, process equipment, etc. Conventional point gas detector, catalytic, 0 to 100% LEL, electrochemical transmitters, 0 to 1000 ppm. Noting that the MSA offering allows to dual the sensors into the transmitter and also allows to remote the sensors, and importantly, this is available in any configuration. Also, flame detection, noting that the unit is hydrogen flame specific. They need to be aligned to the potential flame and breakout points and should not be shielded by any obstacle. Again, walls, process equipment, etc. We now need to review the equipment available. An MSA would like to offer the following. The ultrasonic leak detector, UGLD, will detect down to 2 bar, which is 28 psi leak, has a range of 28 meters by utilizing artificial neural network technology, ANN. However, the units need to be mounted high and be aware of the detection coverage areas. Conventional gas detectors focus on identifying the potential leak points and the gas dispersion possibilities due to piping and plant. Flame detectors review the possibility of any peripheral approach of the location. So mount these high, looking over the area. But again, be aware of any objects, plants, etc. that may shield them. Again, final design. Note that this slide shows a very simplified layout of the detectors. Again, noting that we would propose mounting the UGLD and flame units high, avoiding any solid objects. Again, as I commented, we do offer mapping, is available. And again, if this service is of interest, please join us again at the MSA stand B58. And lastly, these are some examples of installations that we have already made. You'll notice that various technologies are used here. And the few examples show, on the upper left picture, we're showing a conventional detector. The lower left is a conventional flame unit complete with a weather hood. And the two on the right are showing ultrasonic UGLD and flame units. I realize that the timing is very, very tight this morning. Does leave us very little time for questions, although it looks like I've got 1 minute left. So if you have got questions to ask, again, please join us on stand B58. Like I say, it's literally just a walk away. So if you're going for coffees or whatever, you'll be coming past us. It would be great to see you there. And again, thank you for your time and have a great exhibition. All the best. Thank you very much.